Hello and welcome to this quick pitch video on Robustel's Edge2Cloud software. Edge2Cloud is a stack of software protocols embedded in most of Robustel's routers, available free of charge, there's no licensing, and it enables you to move industrial data from the edge directly into cloud platforms like AWS or Azure. And because this is designed to be a quick pitch, the most important thing we're seeing here commercially at the moment is taking Modbus RTU or Modbus TCP devices directly into AWS, Azure, or an MQTT broker of some description in the cloud. But we'll come on to that. But wanted to really make sure that the relevance was high for those that want to reserve their time. So for many years, Robustel have built bespoke applications inside their 4G and 5G routers. And a little time ago, it became apparent that to build a framework to move these industrial protocols to the cloud would help to stop reinventing the wheel each and every time we get a new project. So this is probably the simplest view. So we have the southbound applications. The common ones at the moment are Modbus TCP, Modbus RTU, router IO. We've dropped an output there, but I'm sure you can still understand. So router IO, and in the latest gateway, we also have chirp stack. So we can take LoRa, Modbus, General IO, and other protocols as BLE and Siemens S7 protocols are already coded, just not in full production. So you enable this interrogation at the southbound layer. It then passes up through a broker and then goes straight to your cloud platform of choice. So this is what it looks like in the operating system. There's quite a few things to configure, but this is just a quick view to show that where they live in the original RobustOS operating system. It's important to say it's in RobustOS Pro as well, the new Robustel operating system. And as we just alluded to, this really is the place we see by far the most applications taking something Modbus, putting it into typically an R1520 router. It seems to be very popular for this purpose. And then just transmitting that data, those Modbus reads, straight to the cloud. If we look at the data flow, the protocol flow, one of the important things to mention is that the broker actually has a logging function. So if you lose your 4G connection for any reason, or even your Wi-Fi or your broadband, if that's what you're using, then the data will be buffered. And if you plug in an SD card, for example, in the products that support that, or a USB flash drive, you can have thousands of records being backed up if there's an outage. So just very briefly, this is what a northbound connection inside the router looks to AWS looks like. And this is the view inside AWS device listed by the primary variable, which is serial number. So we're not going really into a deep dive today. This is a quick pitch as defined. And that's the AWS environment. Azure has this nice, simple concept of an IoT hub device string. And with those credentials, you then can add devices to your IoT hub environment. And if you're not using AWS or Azure specific environments, then any MQTT or more likely MQTTS broker in the cloud can be used to receive this data. So publish from the edge, receive the data in the cloud, and then you can visualize that in your application. So that was a quick whistle-stop tour through the PowerPoint. And now we will come on to a live demo of an actual project we deployed based in using Robustel's cloud management system, RCMS, to actually show how it can be managed from the top down. So here we see Robustel's cloud management platform. In this particular account, we have 5 devices. Each of those devices is connected to several Modbus TCP based pulse counters. So there's instrumentation such as electricity meters and flow meters. They're all counting out pulses that could be liters or kilowatt hours, depending on how they're adjusted. There's maybe 30 or 40 end devices. And Edge2Cloud has its own subsection. So the first thing you'll see is just a simple overview embedded inside the cloud platform, just as a reminder for anyone that wasn't clear or didn't see the last piece of the video. And then these are the actual point tables. And so to be clear, a point table is like your Modbus register map and what it is you want your Robustel router running Edge2Cloud. What do you actually want to read? It could be Modbus RS485, Modbus RTU. It could be Modbus TCP. There could be lots of registers or a small number of registers. So here you see in this location, RTU 11_12, which does actually correlate to a real-world project. I've used a slightly dubiously scaled thumbnail. Sorry for that, but I'm sure you get the idea. That is one of the pulse counters to Modbus to pulse counter converter that has worked extremely well. Been impressed with those. And so if we click through now, this is probably the best way to see it, edit point table. You can see that this is how the tags are done, or the channels in Modbus. So the first tag is channel 1, and then you've got channel 2 of the pulse counter devices. So the IP address and the ports are all the same. You can leave the slave ID at the same. The function code 3 dictates is reading 16-bit registers, uint 16, and the register addresses just continue onwards. And so we put together those two 16-bit counts to make one large 32-bit counter and just handle a little bit of rollover. If we get up to 4.5 billion or whatever 2 to the 32 is, we handle that at the application layer. But you can create the template with all the points in there. There's other features as well. We're just sticking with the mainstream capabilities today. And the important thing as well is you can forward to over the air. You can forward to different gateways by selecting any online gateways and pushing it out into the field. Another quick note where, although this is Edge2Cloud, something that dovetails nicely with Edge2Cloud is the robust VPN capability. So these devices could be scattered all around the world. It might be on Wi-Fi, it might be on broadband, it might be on an IoT SIM, but it might be on a local SIM from the high street. It could be any kind of bearer. But as long as you can build a lightweight open VPN tunnel, then you can make an inbound connection based on this open VPN IP address anytime. So that allows you to configure all your cloud-based parameters remotely very, very easily. There are other methods, but that's particularly nice for occasional ad hoc use. So in summary, we have Edge2Cloud and the point table tool. We can generate Modbus register maps, in essence, that we're going to read, and we can deploy them from the cloud. So I hope that was useful. I hope it gives you an idea of what we can do with Edge2Cloud. And if you have any further questions, please reach out to your local Robustel representative or contact support@robustel.com. Thanks very much. Bye for now.